Problem 26. F is a differentiable function defined on the interval 0 to 3, closed on the 0, open on the 3. If for all x such that 0 is less than x is less than 3, f prime of x is greater than 0, and f double prime of x is less than 0, which of the following must be true? Okay, so here's what we have. We have this differentiable function. If it's differentiable, it has to be continuous on this interval. And we know a few things about this. So first thing, let's put right here. This differentiable means that must be continuous. That's going to be important. Second thing, f prime of x is greater than 0. This right here, greater than 0, means that it must always be increasing. It might be increasing slowly, but it's always increasing. Third thing, f double prime of x is less than 0. This means that it is concave down. So concave down. Curving down. It's not going to be as important for our problem, but it's there. Okay, and we can see here that we include f of 0. We do not include f of 3. So let's bring this all together and do a quick little sketch of what this could look like, keeping in mind everything that we have here. So just some axes, 0, 1, 2, 3. And I'm not even going to put a scale up here, it doesn't really matter. But here's the first thing. From this interval, I know I include this f of 0. So don't know where it is, but it's somewhere and it's included. Second thing I notice, I don't include 3, f of 3, but I don't necessarily know from just this whether it's going to be above, level, or below f of 0. But I do see that f prime of x is greater than 0. It has to be increasing, and so if it's always increasing, I know that f of 3, if it were in there, or f close to 3, would have to be above f of 0. So I'm just going to draw this, but it's not included. We have an open circle here. Okay. Next thing we see is that it has to be increasing, but it has to be concave down. So somehow I need to get this concave down, curving down, but always increasing. Let me get that a little bit more obvious, that it's increasing but concave down. Okay, so you can see it's always going up, it's always curving down, not greatly, but sort of like that. And let's see what we have. Now, I could have drawn this any other way, but it has to somehow resemble this graph. And if we look right here, we have a minimum but we have no maximum. The issue is we're always increasing and we include the left point. So we include the lowest point and everything to the right has to be above it. So we have this minimum. We're always increasing, but we don't include the right-hand point. So we approach a value here. We get close to a value. So we approach a minimum. We have a least upper bound, but it's not a maximum because it's not included in the function. So let's go through and see what we have. We do not have enough information to determine whether f has any maximum or minimum. No, we just determined that. F has neither a maximum or minimum. No, it has a minimum. F has both. No, we said no maximum. F has a maximum but no minimum. No. Or E. F has a minimum but no maximum. So my choice is E.